Yeah, we'll talk about file systems. When we design a file system, we think that the entire operating system always consider and recognize and support all the file types. If an operating system recognizes the type of a file, it can then operate on the file in a reasonable way. For example, let us take an example. A common mistake occurs when a user tries to print binary object form of a program or object file of a program. This attempt generally produces garbage results. However, this attempt can succeed if the operating system has been told that the file is a binary object program, so that we won't give any print command. Okay, generally we see here in the operating system provides a common technique for implementing file types is to include the type as part of the file name. It is a part of the file name. The name is split into two parts, a name and an extension, usually separated by a period dot. Its dot is it's also considered as a character. In this way, the user and the operating system can tell from the name alone what the type of file is. What is the meaning of this file? Because this file is separated with the name dot extension. For example, most operating systems allow the users to specify file names as a sequence of characters followed by a period and terminated by an extension of additional characters. For example, abc.txt. The system always uses the extension to indicate the type of the file and the type of operations that can be done on the particular file. This is most important, my dear friends. The system uses the extension to indicate the type of the file and the type of operations that can be done on that file. If text file is a type of the file, what are the operations on text file? If the file is executable file, so abc.exe. Okay, from this we come to know that it is a exe file. It is executable file. It should be executed by the operating system. Only some files with .com, .exe or .bat extensions can be executed. For example, .com and .exe files are two forms of a binary executable files. These two comes under binary executable files. Whereas suppose a .bat file, .bat file, or this is a batch file containing in ASCII format. ASCII format commands to the operating system. This is commands to the operating system. or commands to the command interpreter. Okay, for example, see this MS-DOS operating system recognizes only few extensions, but application programs also use extensions. Operating system use extensions and application programs also use extensions to indicate file types in which they are interested. For example, application programs, example let us see. Suppose the assembler is there. Assembler expects a source file to be or input file to be .asm extension. What is this .asm means? Assembler file. So this is, my dear friends, this is application program. Assembler is a application program is expecting .asm extension. Second example, let us see Microsoft Word processor. This Microsoft Word processor expects its files to end with .doc. Okay, it means document. .doc extension. These extensions are not required. So a user may specify a file without this extension, and the application will look for a file with a given name and the extension it expects. Because these extensions are not supported by the operating system, they can be considered as hints to the application that operates on them. And one more example, most important example, the file utilities of file types we'll see. In TOPS 20 operating system, suppose if a user tries to execute an object program whose source file has been modified. Source file is modified. Since the object file was produced, because from the source file object file is produced, and the source file will be recompiled automatically, because whenever the source file is edited, obviously corresponding object file will become older version. To get the newer version of the object file, whenever source file is edited, that source file should be compiled. The advantage is this function ensures that the user always runs an up-to-date object file. What is the advantage? It runs always an up-to-date object file. Otherwise, unnecessarily, the user could waste a significant amount of time executing the old object file. But source file is modified, but we are running old object file. See the one more example in Mac operating system. In Mac operating system, each file has a type, that is the text file, APPL for application. Each file has a creator. Each file has a creator attribute. What is this creator attribute? Contains the name of the program that created it, this application who created it. This attribute is set by the operating system during the create system call. During this create system call we discussed in the previous class, this create system call will assign the attribute who created this application program. So its use is enforced and supported by the system. For example, a file is produced by the word processor, any word processor like Microsoft Word, has the word processor name as its creator. Whenever we want MS Word, if you open new, with that name only it will be created. Okay, Microsoft Word, that logo will come, right? When any user opens the file by double clicking the mouse on the icon representing the file, the word processor is invoked automatically. So whenever we'll double click, that word processor is invoked automatically and the file is loaded, ready to be edited. We'll see next example in the Unix systems what happens. The magic number. A magic number is stored at the beginning of some files to indicate roughly the type of a file. Is it executable program, batch file, or shell script, or PostScript file, and so on. All files, not there is, it's not compulsory. Not all files have magic numbers. Some have, some may not have. Okay, it is depends upon the application programmers. Let us see this. These are the file type, file the diagram. Now what we are seeing on this picture, file type, all these are executable object, source code, batch file, text file, word processor, library, print or view, archive. General extensions are given here: exe, executable.com, .bin, object.obj, source code .c, .p, .pas, .asm, .a, batch extension .bat, .sh, textual data documents, text type .txt, .doc, word processor .text, .wp. Now word processor we can use .docx. Now library .library lib, like .zip, .tar. These are all the file extensions, and a file name is, it's having two parts. One is name of the file followed by dot character followed by its extension. Now we'll discuss about sequential access and direct access. Files store information, and when it is used, this information must be accessed and read into the computer memory. And this information in the file can be accessed in several ways. Some systems provide only one access method for the files. The other systems, such as of IBM, supports many access methods. Sequential access simple method. The information in the file is processed in order. One record after the other will be accessed. This mode of access is by far the most common. For example, the editors and compilers usually access files in this fashion, and its operations are read next, write next, reset, no read after last write, rewrite. Let us discuss this. Reads and writes make up the bulk of the operations on a file. A read operation, read next, reads the next portion of the file and automatically advances a file pointer, which tracks the input-output location. Similarly, the write operation, write next, appends to the end of the file and advances to the end of the newly written material. Such a file can be reset to the beginning. And on some systems, a program may be able to skip forward or backward end records for some integer n. The maximum is n is equals to 1. Now we'll see the direct access method. The direct access method is also called as relative access. The file is made up of a fixed length logical records that allows programs to read and write records rapidly in no particular order. Rapidly we can access the record. The direct access method is based on a disk model of a file. Since disks allow random access to any file block. For direct access, the file is viewed as a numbered sequence of blocks. Each block has a number. A direct access files are a great use of immediate access to large amounts of information. It is used to access a large amount of information. For example, databases are often of this type. When a query concerning a particular subject arrives, we compute which block contains the answer and then read that block directly to provide the desired information. Okay. Next we'll see a block number provided by the user to the operating system is normally a relative block number. A relative block number is an index relative to the beginning of the file. Thus the first relative block of the file is 0 and the next is 1 and so on.